Hello students, welcome. In previous lecture we discussed about quantum numbers and we learned that we have four different type of quantum numbers. Quantum numbers are one type of address system for electrons present in atom. So let us quickly recap it. We have four different quantum numbers and first of all we have n, that means principal quantum number. Principal quantum number generally it is described with digits 1, 2, 3 and so on. It is also represented in form of shells. In form of shell we will represent it in term of alphabets K, L, M and so on. Now what it represents? So principal quantum number represents energies of electrons and distance of electron. As the number increases, distance of electron from the nucleus also increases. Then we have second quantum number. Hello students, welcome. In previous lecture we discussed about quantum numbers and we learned that we have four different type of quantum numbers. Quantum numbers are one type of address system for electrons present in atom. So let us quickly recap it. We have four different quantum numbers and first of all we have n, that means principal quantum number. Principal quantum number generally it is described with digits 1, 2, 3 and so on. It is also represented in form of shells. In form of shell we will represent it in term of alphabets K, L, M and so on. Now what it represents? So principal quantum number represents energies of electrons and distance of electron. As the number increases, distance of electron from the nucleus also increases. Then we have azimuthal or subsidiary quantum number L. Generally L will start with 0, then 1, 2, 3 and so on. Value of L depends on n. Value of L will start from 0 up to n minus 1. That means in given principal quantum number we have 0 to n minus 1 values of subsidiary quantum number L. So suppose we have n is equal to 1, then you will get only one value of L, which is 0. If we have n is equal to 2, then you will get two values of L, which is 0 and 1. That means n minus 1 is equal to 2 minus 1 is equal to 1. Now we can represent these L values with digits, alphabets as well. 0 represents S, 1 represents P, 2 represents D and 3 represents F and so on. We will learn till F because in our periodic table all the elements contains maximum up to F orbitals. Next one is magnetic quantum number ML, and value of ML depends on L. Value of ML will start from minus L to plus L. That means if you have L is equal to 0, then only possible ML value will be 0. If L is equal to 1, that means ML will be minus 1, 0, 1. If L is equal to 2, then ML will be minus 2, minus 1, 0, plus 1, plus 2. And if L is equal to 3, that means F orbitals, then possible ML values will start from minus 3 to plus 3. So it depends on L value. And last one is spin quantum number MS, or sometimes it is also referred as S. It represents spin of electron. If we assume electron as a spherical ball-like shape, then electrons are spinning on their axis. Suppose if we pass an imaginary axis through this sphere, then this sphere will rotate on this axis like this, just like Earth is rotating on its axis. So we have two different possibilities. Either it will spin like this or it will spin in opposite direction, that means like this. Okay, so if first is represented with plus 1 by 2 sign, then second one is opposite, that means it will be minus 1 by 2. So we have two different values, two possible values for last quantum number, which is plus 1 by 2 and minus 1 by 2. Now, as mentioned earlier, for given principal quantum number, possible azimuthal quantum numbers will be equals to principal quantum number. If principal quantum number is 1, then we have only one possible value of L. If you have 5 as a principal quantum number, then you will get 5 different possibilities for L value. So that means maximum possible value of L is equal to principal quantum number. And second point, subsidiary quantum number will start from 0 and it will end at n minus 1. That means maximum possible value of L value is always less than principal quantum number. It cannot be equal to or greater than. Similarly, relationship between ML and L. So as mentioned earlier, values of ML depends on L value, and it will start from minus L to plus L. So it can be greater than or smaller than this range. That means if L is equal to 2, then possible value of ML will start from minus 2 to plus 2. It cannot be minus 3 or plus 3. These values are not possible. Minimum value possible for ML if L is equal to 2 is minus 2 and maximum is plus 2. It cannot be beyond that. Then spin quantum number S depends on MS. In given MS value, two possible values of S are plus 1 by 2 and minus 1 by 2. If one of them is plus 1 by 2, then second one must be minus 1 by 2. That means in given orbital, maximum possible values of electron is equal to 2. If first electron has spin in positive value, that means let us say in clockwise direction, then second electron must spin in anti-clockwise direction. Now let us understand these points with an example. Here we have a set of quantum numbers for an electron present in atom. So our target is to find whether this configuration or quantum numbers are possible or not. So let us discuss our points. So let us start with principal quantum number. So here our principal quantum number is 3. So that means electron is present in third orbit, which is possible. Now our azimuthal or subsidiary quantum number value is equal to 2. So as mentioned earlier, value of L must be smaller than n, and it is smaller than n, so it is possible. Now ML value is minus 1. So as mentioned earlier, ML value will start from minus L to plus L. So here ML value is minus 1 and L value is 2. So that means it will be between minus 2 and plus 2, and minus 1 is between minus 2 and plus 2. So it is possible, and S value will be either plus 1 by 2 or minus 1 by 2. So here S value is mentioned plus 1 by 2. So it is true. So these type of electrons can be present inside the atom. Okay, second one, n is equal to 2, L is equal to 2, ML is equal to 0 and S is equal to plus 1 by 2. So let us start with principal quantum number. It is 2. Now subsidiary quantum number, it is also 2. So as mentioned earlier, L must be smaller than n, and here they are same. So that means these type of electrons cannot be present inside the atoms. Okay, no need to check further. Okay, next is n is equal to 3, l is equal to 2, ml 3 and s minus 1 by 2. So if n is equal to 3, then it will l is equal to 0 to 2, and it is 2, so it is possible. Now if l is equal to 2, then ml values will be between minus 2 to plus 2, and the ml value for given electron is 3. That means this type of electron is not possible, and S value is either minus 1 by 2 or plus 1 by 2. Okay, so this type of configuration is not possible. So now we have a little exercise for you. So here two different sets of quantum numbers are mentioned for two different electrons. Your target is to find which of them is possible and which of them is not. We will discuss about answer in next lecture.